want to quickly go over that pro. I'm not going to bore you to death with stats and have you all run away quickly. But I do want to give you some context, and I think that context helps you write your paper. And then we'll actually go through the data file on Excel. I'll share my screen and we'll run the exercise together. Given that actually works, that I can share my screen. And then we'll make a graph. You'll get your mean values for the set and your standard error. And then I'll answer some questions if you have them about the lab. So are there any questions right now before I get into it? Any confusion about what we're doing here? I'll wait a second. And basically, you are more or less yourself, object, a biological being that has instruments on it, send the environment. You make predictions about what might happen in the future. And I think a really good misunderstanding of variation and probability, which is what statistics is all about, is the data frame that you create. So human beings are terrible with the dimension of time. We can't see beyond our own lifetime, and that's totally fine and fair. But the coronavirus seemed like that would never be a thing. It never crossed my mind. I heard about the Spanish flu maybe once and forgot all about it. But now, since the reference, we have one occurrence of such a pandemic, the probability is suddenly much higher that this sort of thing might happen again, because within our lifetime, we have that data point, we have that occurrence. So without getting too fancy on you, we live in an uncertain world. And the way you go about recognizing patterns, it's important to frame the data set that you're generating. So if you're looking at how many pollinators are visiting flowers, maybe you just go in the afternoon and you've totally missed what happens in the morning, or you've missed a seasonal pattern, and that's just important to keep in mind. And I'm not going to go on about that too much. And then the other things that we are interested in are especially the mean of the data set. So that happens to be about the distribution of probabilities. So you collect a bunch of data, you're getting the average of where your data set will lie on a probability that's, we're going to assume, normally distributed. It's not too important to get into that, but essentially the measure of location, where your data is lying in the realm of possibilities, and then how much variance is associated with that. And there's standard variance, or standard deviation, standard error, and a few other things. So things on these flowers. I've split the data set into hermaphrodites and females, and the most important things to do are to get the mean. So in the realm of possibilities, where does the data of female flower length lie and hermaphrodites lie? And then to get the spread or the variance, either a standard deviation or a standard error of that mean. And so we'll get those values, and then we'll just simply plot them. And that's it. I don't want to take too much time on it. It's really not overly complicated. I'm running on a Mac, so I don't have that data analytics package. There's just that function that was available on the data t-test in Excel that looks like this file here. So you guys on PCs, you'll be able to pull up a proper ANOVA or t-test using the data analytics package. So this is like an instruction on where to get it. You go to your options, you upload it, it shows up nicely, and then you just select t-test. It's all beautiful for you. But for us, living on the Macintosh, for some reason the package is no longer there. There's plenty of ways to analyze data, and Ivana left you a URL on the assignment to a separate way to do the t-test in case this fails for you. But I'll be using this little t-test function. So step one, Excel and every program is really finicky with how you organize the data. So the first file I put on was how I would organize it in a program called R, and Excel won't handle that that very well. So I've just reorganized here, and we're setting ourselves up right now in real time to make a graph. But what we're doing is getting the mean and the standard deviation. So we'll just do standard deviation today. I can quickly show you standard error. For the paper, it doesn't matter. Um, Huge debate over standard deviation as a metric of the total population versus standard error. Um, if you're measuring standard error of the mean, you should be sure that the sample you've collected really represents the true population. So there's just a bit finicky. I don't really care for the paper what you use, standard deviation or standard error. So enough of that. We'll continue on here. So we're going to just set it up like this, where we have term and female, so you don't mind the short form. And we're going to calculate mean. Is this large enough for everyone? You can probably zoom in um, on Blackboard. So I'll just make it a little bit bigger. Sorry about that. Okay, and we'll just put standard dev up here. So I don't know what everyone's experience with Excel is, but the function to get a mean is simply average. So you click on the cell, you hit equals, and then you are going to type average, can be in lowercase. You're going to have a parenthesis open or bit open, and then you're going to drag the data set that you want to collect the average of. And so follow with me. We're just going to drag down. And at any point, if things are blowing up on your end you're stuck, just jump in and let me know, and I can try to troubleshoot with you. So we're just going to have to boringly drag this thing all the way down. My computer's probably slow projecting in this virtual world to 14 of you while computing, which is interesting. So easy to think about. Okay, so I've dragged too far. This is our average here, so we're going to close it. I just put a bracket on the end, and then you're going to hit enter. And if the magic worked, you have our mean. So our mean for hermaphrodite length is 18.9 millimeters. And just to reassure ourselves that we did it right, you can double click the cell and then see the array that you've copied. So we'll do the same thing for females. Average. And if anyone's having problems, just type in the chat. Just say problems, and then we'll try to address them. But this is nothing extremely complicated, and there's probably a bunch of YouTube videos of maybe a slightly funnier guy or girl or neutral explaining all of this better. So sorry if this sucks, but we're just dragging down the array. And then once we've done this, we'll calculate our standard deviation, and then we'll graph it. And you'll see that, like, really, without the yammering, in about 10 minutes, you can do everything you need to do. So we'll hit enter here. And I'm choosing to do standard deviation because standard error is a little bit more tricky. It involves the square root. You're dividing the standard deviation by the square root of the total number of data points that you have. So it's an extra thing to add into the cell. I'm not gonna do it. So the function for calculating the standard deviation of a data set, like average, it is STDEV for standard deviation. I think we can get away with lowercase, so we'll at least try. And then just like the average or mean, you drag down. So again, I should have some like background music going for this. And yeah, I appreciate you all populating the Excel spreadsheets and being timely with all of that. And thanks for being good participants in a virtual lab and rolling with what the semester brings. So just we're messing around here. It actually means a lot to me that you guys are active and doing things, and I encourage you to continue no matter how bad things get on your end. We're all here for you. So standard deviation, I close the parentheses and I hit enter. And that is the standard deviation of our hermaphrodite data set. So we'll just do the same thing for female. There is some dragging functions that I could do here that would make things quicker, but just for this tutorial, I'm just going to drag. So any questions arising so far? Is this all pretty okay, pretty intuitive? Feel free to jump in on the chat or raise your hand. But if everything's cool, then I'll just keep going. And I do want to say as well that that preamble was really written by quite a beautiful guy thank you, at Harvard Forest long-term research plot. The guy's name is Aaron Ellison, and he's a funky dude with a ponytail that walks around the forest playing guitar and monitoring ants, going about ant ways. And he realized, teaching statistics to undergraduates and graduates, that there was this barrier in everyone's mind that just caused them to freak out as soon as you mention the word statistics. And that really is just a thing about patterns and making sure you're appropriately addressing the pattern, because we can't be trusted as fatally flawed human instruments. So thank you to Aaron Allison for his book writing. He wrote the statistics book, the primer for ecological statistics, and Nembo was based really off that. So now you're looking at the mean and standard deviation, and what do you know it? That is quite a difference of mean, and usually, so we'll see when we do our t-test, but normally you can tell there's a significant difference if the difference in the mean, so here we have a difference of 8, almost dead on actually, 8 millimeters between the two floral sizes, and the largest standard deviation is 4. So we can be pretty rest assured that there's going to be a significant difference. So now let's graph it, and we'll do a bar graph, and hopefully you guys are all still following along. And I think the way to go about this, I don't really use Excel, I use the R program, but you go to insert. So what I've done is I've dragged the sex column, and I've dragged the mean column. I've left out of that data frame this deviation for now. We'll add that in later. So I've just highlighted those. I just dragged the 4 cells, and I think insert the 2-dimensional clustered column. 3D is not a thing. Excel should just take these out of here. No one does it. If you're doing 3-dimensional bar graphs, you should have a good reason to do so, basically. So we're just going to click this clustered column, and there you go. You have a bar graph, and it's not pretty. It's basic right now, but look at that. You guys, it hasn't been that long, and we just did it. So congratulations. Now we'll want to add some things. So did anyone have any problem making this graph? Was that an issue for anyone at all? Just getting to this bare bones bar graph? No? Okay, great. And you can see the difference here. Like that's quite a large difference. So now we're going to add some stuff and take away some. Excel has junk in the trunk, so we'll just try to sort out all of that and just make a graph that is really, the better the graph, the better you've conveyed the value, the meaning. And often scientists will go into a paper, look for the figure, try to see if they can understand the whole paper by the figure, and that should be your goal, is to clearly show the whole signal. The whole point should be in a figure. You can forget the abstract. If the figure is good, that's good enough. So you want to invest some time doing what I'm doing here, and that's going to be adding some axes titles. So that was on the left-hand side. It's this add-in little drop down, and right now we don't have our titles for our axes. So horizontal, you can put gender or sex or whatever, and you can change the size of all of these, and we'll add another axis. So that would be our primary axes, and this is length. Whoops, length in millimeters. I won't go further with like any removing the background or anything. I don't want to waste any of your time, but you should be able to figure out how to take away these background lines. I think on the instructions it says not to have the title like that, and I wouldn't recommend it. The below your figure, you're going to put what the figure description is. It's called a figure caption. I'm pretty sure it's laid out in the project file. So just make your graph a little bit pretty. If you quickly how to do that in a few ways here. Now I want to show you how to add the error bars, and I did this just for practice this morning, and I'm not 100% sure if it works entirely or not. So double check on your own, and if there's problems, just email me. But yeah, I'm not. Let's say my probability. I'm a little bit uncertain about the error bars. So you go to if you click standard deviation on right now, it'll make some nonsense error bars that are quite clearly wrong. So the thing to do is to go to this bottom option, which is more error bar options. And what will come up, if you can see on this right-hand side, is you want direction. So it's generated some standard errors already here for us, and I don't think they're right now because they're both the same. And the direction should be both positive and negative. So that variation, the spread of the data, is equally likely to be above and below what the mean is. And that's why you should have both positive and negative. So both, I think cap is meaning it'll have a little horizontal cap. So instead of fixed value, what we'll do, and again, this is the part I'm not 100% sure on, is specify value, and then I believe you drag the standard deviation column for both positive and negative. And then I think you hit OK, and that looks kind of reasonable. I think that's right. Yeah, I think that's how you do it. You don't have that option in your Excel. Interesting. So maybe that is a newer thing. Does anyone else not have the more error bar option? It might be. Are you using PC, Sana, or Mac? Mac. Interesting. So I'm not sure why. Maybe you don't have an updated version. Does anyone else have any issues with that error bar part? So Sana, if like you and I can email communicate if you want. I'm not so sure what version I have. It would be, let me see. I have version 16.41. Whatever that means, I don't know. It's the newest one that is with the U of T email account. So maybe update yours and go from there. Huh. So are there two people that weren't able? Anyone else? Did anyone have success doing it? So did anyone have success with those error bars? Okay. Yeah, so for those that didn't, maybe just try try to do it on your own accord. Just Google with whatever version you have, and Google will find an answer. And if not, just email me, and I'll spend some time on it. But I'm not gonna drag this on too long. So we're almost there, guys. Congratulations, you've got your graph. It needs to be a little bit prettier, but it shows the means. We've got our error bars, so that's standard deviation. And now we're going to do that t-test thing. And this, again, will vary between the PC users and Mac users. I am just going to use both PC and Mac can use this code here. Guys, Adobe. I just want to show you the code. So this is, or a function, and it's this t.test, and then you copy the two arrays that you're comparing, those two columns, and then it's a two-sided test, and we're not pairing the data, so it's just going to be a two sample. So all you do, you can copy this, or you can type it in manually. For those that have PC, there's a little prettier way to do it, and that involves downloading the analytics tool package. You get like a nice drop down and all this slick stuff. You get look at that readout, all these kind of things. This bare bones is bare bones. So you get a p-value, and that's it. For the assignment, that is all that's required with the graph. I think that's fine. There's probably a lot more ways to do the t-test in Excel than I know of. This was just one way. So we'll just do that now. There's the other option on that website that Ivana provided. And otherwise, like I can help you in any program. I did this all in R, and it was beautiful and really simple. So I can help you with that too. But for this exercise, we're just going to copy and paste that function. Uh-oh, my computer doesn't like that. Uh-oh. I see some loading issues. Okay. So if you've managed to not blow up your computer and you're still here, we've copied and pasted that little function in, and instead of array 1, we're just going to, like we did with average and standard deviation, highlight that entire array, and just some waiting lobby music going in your mind while you're dragging things down. And then you'll drag the other array and then just type in manually the options 2 and 2. And then the results will be the p-value. Uh-oh. I've dragged too far. What a drag. Sorry, like puns, so if we have more help sessions, you'll have to get used to the puns. I can't help myself with it sometimes. I think you've been lucky so far. So this is our second array, and you can see it's in a different color, and I'm just dragging it down, same thing. And what the function is doing, it's testing the two data sets against each other. And for this assignment, we're assuming the data is normal and that we're allowed to do this sort of thing. I can kind of secretly tell you, don't tell anyone, the data is kind of not normal, and there's probably a better way of doing this that's a little bit more accurate, but for this exercise, it's fine. And the reason it might not be normal, intuitively, right now, you can see there's white space, so it's an unbalanced data set. There's far more values for the female flowers that were recorded than the males, and that can, or hermaphrodites, and that can really throw off your data set. So we have the two arrays in our little function, and we're going to change this tails to 2 and type to 2, and that was just from that little tutorial, and that means it's a two-sided unpaired test, and we're going to hit enter and hope that something happens. Uh-oh, there's a problem. So let's see here. Uh-oh. There's still a problem with this formula. So let's see. Oh, geez, of course. Maybe it didn't like. So we'll try to troubleshoot. Did anyone have that work, or are you running into the same issue here? Mine worked. Okay. Well, great. What did you guys get? You know what? It might be that I copied the sheet. So what was your p-value? You want to type it in the window? Let me just see if I can troubleshoot what this issue is. Yeah. Okay. So you got a really low p-value. So perfect. Did anyone get the same error that I have right now, or are you guys okay? No one had the same error. Okay, so as long as it works for you, I promise that this does work. Right now, I have no idea why. Maybe I just dragged something by accident. But that p value that Rebecca stated there, it's kind of funny. This isn't working. But the p-value that Rebecca stated is right. It's very low, and basically, the p-value, if it's less than 0.05, then it's a significant difference, and we can see that looking at the chart already. And as I said, if the standard deviation is not as large as the difference of the means, you can pretty much guarantee it's significant. So as long as you guys are actually able to hit enter here, then I don't care to solve my own problem. But if anyone else is still having problems with this t-test thing, it's probably I just copied something. Excel has ghost formatting. I swear that'll bite you like like you've never seen. So in Excel, when in doubt, just escape out and start anew. So unless anyone else is having extreme problems, I'll just open up the class now to questions, and it can be questions about any